All right. Okay, so we went right before the break. Let's pull up this slide. That's what we looked at, the most complete configuration of an MDB. So we talked about the structure of an MDB with the annotation. We talked about the configuration information. And then we mentioned the fact that onMessage is the one business method that we have to implement to truly be a message endpoint. So the focus now is how do we do proper message handling. The key thing to recognize is that the messaging system is not going to actually do filtering for us. So when we do the configuration, it's not like we say as part of the configuration, I want to receive all messages at XYZ topic that have ABC contents. We just say we want to receive all messages at some destination. So it's our responsibility as a developer to basically perform our own message filtering. The easiest way to do message, I shouldn't say the easiest, but the most straightforward way for us to do message filtering is just through, some Java code. Because there are, in the JMS world, there are about 10 different types of messages. I don't know the exact number off the top of my head, but let's say it's 10. Because there are like 10 different types of messages, the first thing I generally want to do is I want to make sure the inbound message is a type that I can handle. So in this example here, we just check using the instance of operator to see if the inbound message is a text message. There's the other alternate there is an object message, and then there's a few more. Obviously, if it's a text message, that means the payload is string-based or text-based, which, basically affects how I'm going to retrieve the data out of the message and what I'm going to do with the data after I've retrieved it. The second way to do filtering is that once I've identified the messages of the appropriate type that I'm looking for, then I could use message properties. There are some message properties that are set by developers, and then there are message properties that are set by the messaging system. Those are generally called headers. So I could use both headers and properties to do additional filtering. And then after I've used headers and properties, then the last way to do filtering obviously would be on the payload. So that's a really simplistic way. If I throw an exception out of the onMessage method, what's going to happen is that's going to tell the application server, which in turn tells the messaging system that I did not handle the message. And then the messaging system will then try to redeliver it to the endpoint. So one of the things to be aware of is that if I do throw a message, I might actually get the message back again. And if I couldn't handle it the first time, it means I can't handle it the second time. So I need to build in some strategy on how to deal with kind of those message handbacks. So that's a kind of a primitive way to do message handling and message filtering. But like I said, it works fine. The second way is kind of a newer way, and that is to use something that's known as a message selector. A message selector really is a way for me to supply criteria as part of the activation configuration. And what's going to happen is that when the application server receives a message from the messaging system, before the application server actually hands the message off to the MDB, the application server is going to apply the criteria that I specify against the headers and the properties in the message. And if the criteria match, it'll forward the message onto the MDB. If the criteria don't match, then the application server doesn't forward on the message. So this obviously is a little bit more of a robust structure because I'm not quote-unquote codifying the filtering criteria or the selection criteria. I'm placing it in metadata. And even though the example that we've got in front of us here shows the metadata, the criteria baked into the metadata as part of an annotation, remember I always have the option of putting this selection criteria in an XML file. So the thought process here is that if I wanted to change the filter criteria, I'd externalize it into an XML file, and then I could change that filter criteria dynamically without having to redevelop and recompile and repackage my entire application. So at that point, all I would do is reassemble the jar if I'm using XML. But the way that this is going to work simplistically is that, again, there are both headers and properties. Some headers and properties are set by the messaging system. Some properties are set by me, the developer. Generally, it would be called the message producer. In this particular case, the message producer generates a property that has the name message selector. Java's case sensitive, right? So that's obviously going to be case sensitive. And then you'll notice here the second criteria is the property value. And in this particular scenario, we're saying, hey, if the value is add, then we're going to go ahead and handle the messages. If it's anything other than add, then we're not going to handle the message. So the thought process is that I could create a really complex selection structure using this SQL-like notation where I can have identifiers, literals, comparisons, so on and so forth to really filter out the types of messages that I'm working with. Depending on the type of destination, if there's a message that comes in and it doesn't meet the selection criteria and I'm dealing with a queue, for example, it's just going to sit there on the queue indefinitely, so to speak, until a message handler comes into play that can handle the type of message. So I mentioned before there are these headers and properties that I can deal with for message selection. There's just a short list. The JMS headers are things that are set by the messaging system. I don't have control over those. Obviously, I do have control over properties and the values of those properties. And then in terms of literal values, again, because I'm dealing with Java, we mentioned the casing for strings. I also have to delimit single quotes with a single quote. I don't know if you've ever used the formatting packages that are part of java.text, but it's the convention that the formatting packages use, formatting classes use. True and falses, literal values, things like that. And then as far as comparisons go, I've got basic mathematical comparisons, but then here's the SQL-like operations as well, like in, not, is null, so on and so forth. So a couple more concrete examples to look at. This one says, hey, if the property value of the property name message selector is add, then I'm going to go ahead and process the message. This one says, hey, if the value of the property operation is multiply and the value of the property result is 100, then I'm going to process it, right? And this is, a little bit more complex. If the value of the property operation is multiply or add, and the result is greater than 100, obviously I'm going to go ahead and process the message. So just externalizing the filter criteria into some metadata. And there's just a codified example of that. So the other thing I can do is I can change from a message handling perspective. I can change the acknowledge mode. If the message matches the criteria and on message doesn't throw an exception, then the container is just going to assume that I acknowledge the message request and send that back up to the messaging system. There are a few different values that you could look at changing. Obviously, if I want to have the most control, then I'm going to control the acknowledgement. I can make the decision. There's also this thing called dupes OK. The idea there is depending on the messaging system and depending on the destination, it is possible that I could receive the same message twice. And so you could just set a configuration flag that says, yeah, that's okay, or no, that's not okay. And that just, again, really depends on the business case and what you're trying to achieve. All that's being said, the stuff that we're looking at from a configuration perspective really comes out of JMS more so than EJB. We're just taking JMS properties, so to speak, and applying them within the EJB world. So if you really want to know more about that, the best place to look is JMS and the specification and the documentation there. Questions on message-driven beans?
Do we have an annotation at peak?
At peak?
Yeah, to peek into a message in a topic?
I am not familiar with that. No.
And with the configuration, can you set up the specific ones like you were showing and then have kind of a catch-all?
What do you mean?
Well, where we've got 3 different types of beans that handle, where it's greater than 100 or less than 4 and whatnot, and then have a bean that just catches all the kind of overflow text messages?
Sure. Yep. Yep.
And so that
so you're just saying that you would have different like if you had 4 beans, you had to have different selection criteria on the first 3, and there'd be no selection criteria on the 4th.
Right.
Yep.
You'd have to run in the right order, though.
Yeah, you'd have. Well, there's a couple of things you'd have to do. One is you'd have to use a queue and not a topic. And then as far as ordering goes, you would have to definitely make sure that each selection criteria was unique and there was no union, so to speak.
Yeah, but the catch-all would get all the messages.
The catch-all would get all the messages. Yep.
Okay.
Yep. Yeah, that's a good point. If it, that's a good point, Robert. There's no way, I don't know of a way to tell the container which order to deploy things.
You'd have to have if you had one that said select, greater than 100 and one that said select, less than 50, you'd have to have one say select one where it's not greater than 100 and not equal 50 or something like that.
Yep, exactly. Exactly.
You'd have to catch all the rest of them like that.
Yep.
Okay.
Yep.
But if you have 2 of them which, if it matches the criteria, would it deliver to both? Or
yeah, that's... Okay.
Well, queue is going to be delivered to one endpoint unless the endpoint doesn't properly handle the message.
Well, what if you had a selection criteria of X greater than 50, and on another MDB you had X greater than 100, and the numeric value was 200?
First one to get it.
Do you know?
First one, yeah. Right. First one to get it.
No guaranteed order.
Yep. Exactly.
That's scary.
Uh-huh.
Yep. So you would have to do greater than 50 and less than 99, and greater than 100 and less than 200 or whatever.
Unless you do a topic, right? Then they both get it.
Right. Then they both get it. Yep. Exactly. Yep. Other questions? Okay, so let's talk about interceptors. Are you guys familiar with the idea of aspect-oriented programming at all?
Mm-hmm.
No.
Okay.
No. Some yes, some no.
Okay. All right, so it's a little bit mixed. the simple way that I'm going to define it is that instead of having common utility code exist in every single object or exist in every single method within an object, aspect-oriented programming basically says, why don't we just externalize that and apply the aspect, whatever it is, to the code, to the object, either before we do a method call or after we do a method call, before we do construction, after we do construction, things like that. So it actually is more object-oriented than me physically implementing a log call in every single method, because I'm encapsulating all the logging functionality into a single class, so I have high cohesion. AspectJ, I don't know, maybe came out 8 years ago or something like that, and that was, at least in the Java space, that was the kind of the big push to create aspect-oriented programming. And then, obviously, when the EJB world tried to simplify things, they borrowed a lot of trends in the industry. They looked at AspectJ, they looked at aspect-oriented programming and said, this is a good idea, we should apply it to EJBs. So, from an EJB perspective or a Java EE perspective, for whatever reason, we can't use the terminology aspect-oriented programming. We have to use the term interceptor, whatever. It's the same idea. The reason it's called an interceptor is that the interceptor class itself physically intercepts the invocation and gets to choose whether or not the invocation is forward to the bean is handled directly or does some pre-processing for it and then potentially some post-processing. So it truly, can truly prevent, for example, the invocation of a function on the physical bean if I wanted to. Or I could do pre-processing and post-processing if I wanted it to. From a visual perspective, the way to look at an interceptor is that it's going to provide one more layer around the physical instance, around the physical EJB instance. Proxy is always there, can't get rid of that, but this interceptor basically sits between the proxy and the physical EJB. Of course, I could have multiple interceptors surrounding the EJB if I wanted to. Interceptors can actually be ordered, so I can define the order in which the bean is wrapped. So maybe I would have a security interceptor, and then I would have a logging interceptor, and then I would have a data validation interceptor or whatever, and they could all wrap around the EJB. To create an interceptor is pretty straightforward. We're going to look at that in a second. I'm just going to generally create a class. Everything within the Java EE world always executes in some type of context. So when I go to create my own interceptor, it's going to be executing in what's known as the invocation context. And the invocation context, simplistically, is just a way for me to get a reference to the bean that I'm going to invoke, and a way for me to get a reference to the method and the parameters and so on and so forth that I'm going to interact with. If you're familiar with the reflection API, it's kind of a streamlined representation of the reflection API, specifically for intercepting function calls on EJBs. So the point there is that when I go to create my interceptor, I'm going to have to interact with this invocation context to grab whatever I need to grab to either do my pre-processing, post-processing, or if I just want to do invocation on the bean, I'd call proceed. Three primary types of interceptors. There are business method interceptors, and the idea there is that I'm either going to apply an interceptor to a specific method in my EJB, or I'm going to apply an interceptor to all methods in my EJB, or I'm going to do a combination. Then there are lifecycle callback interceptors. So the idea here is that if I've got a post-construct lifecycle callback method in my bean, I could also create a post-construct lifecycle interceptor. So before the post-construct is invoked on the bean, the post-construct is invoked in the interceptor first, right? And then I have pre-processing, post-processing, forward options. And then the last one is the timeout interceptor. We haven't talked about the timer service, but if you ever dove into the timer service, there's a thing called a timeout. It's annotated with an @ sign and then the word timeout. That's invoked by the timer service when the timer goes off. So again, I could create a timeout interceptor if I wanted to. The easiest way for me to create an interceptor is what I would call this business method interceptor. More specifically, I would call it a business method, business level interceptor, which just means that I'm going to create a method in my EJB. I'm going to annotate that method within my EJB using the @around invoke, and then whatever method is invoked is going to go through that interception method. So the interceptor, another way to say it is that the interceptor is within the bean itself. So that's not really, from an aspect-oriented programming perspective, it's not truly aspect-oriented. I mean, it is at some level, but we haven't externalized anything because everything's kind of co-resident within the one object. But it, again, is the easiest way to do it. So let's look at an example. This is a very basic example. The idea here is that, again, sticking with my calculator, I've got this log operation. See, the log operation is assume that it's in every single method. The log calculation is down here. I could, from a programming perspective, just keep, inserting log calculation for every arithmetic operation I provide within my calculator. That's fine, it works. Obviously I have redundant code, so it's not the most elegant thing in the world. A better strategy would be to quote-unquote intercept each one of the method calls and apply the interceptor. Because then I've got the code centralized within my EJB. It's one place. If I need to change it, I'm changing it in one place, so on and so forth. Because I'm using an interceptor, it's guaranteed to execute, so I don't have to worry about somebody forgetting to add that one log calculation call, so on and so forth. So here's a refactored representation. Generally looks the same for add and subtract. You'll notice the log calculation piece is gone. But now what I do is I create this interceptor method functionality by taking the standard log calculation, adding to it the around invoke annotation, and now every single method that's invoked within that class is going to get intercepted. And all that method's doing, if you're not familiar with it, is generating a JMS message and sending it off to the message queue. So, very straightforward way to create an interceptor. Again, I'm not externalizing the aspect. So the next way for me to create an interceptor is truly to go through the externalization of that concern. So the way that I'm going to do this is I'm just going to create a class, standard Java class, POJO, so to speak. Got to follow those Java Bean conventions in that it's a public class. It's got a public no argument constructor, all that great stuff. And then you'll notice in here I just go ahead and create whatever method I want it to be and surround it or apply the annotation with the around invoke, and then it functions as the interceptor. In order to physically invoke the objects method, or in order to explicitly invoke the beans function, you'll just want to make sure you do this ic.proceed, invocation context.proceed, and that behind the scenes is going to call whatever target method it is on the bean. Return, obviously you want to return the results. We don't know. The thing is that we don't actually know if the method returns anything. The because we don't really know what the method looks like from an interceptor perspective, but we always want to do a return, in case the method the actual target method does return something, we want to pass that up the stack, so to speak. And then once I've defined that interceptor, I have the option to either apply the interceptor at the class level, or you'll notice I also have the option to apply the interceptor at the method level. So if I do apply the interceptor at the class level, it's really like the first scenario we looked at, where the interceptor was co-resident within the EJB. It just means every single method in that class is going to go through the interceptor. If we apply it at the method level, it basically says only this method, SumMet, actually has an interceptor associated with it. So all the other methods in the bean will run interceptorless, so to speak. So obviously, if I externalize the interceptor, I have a lot more fine-grained control over where the interceptor is applied in terms of my methods. Simple example. Simple example here. Again, I've got my bean. What we've done is we've externalized that log calculation out of the bean, placed it in this calculator log interceptor, applied that interceptor to the class, and then if I were to look at the calculator log interceptor, here's my log calculation operation that we saw in the previous example. Still has the around invoke. And now every single method invocation that occurs in that class is going to be intercepted. Quick note about interceptors. If I said earlier when we were looking at the picture with the orange ovals, I said that you can have multiple interceptors applied to a class or to a bean. So what would happen is that I would create right here in my list, or my interceptors annotation, I would create a comma delimited list. It is an ordered list. The first one is the first interceptor applied. Second one after the comma is the second interceptor. The third one after the comma is the third interceptor. The slight variation to that is that, remember, I can apply an interceptor at the class level. Right, I can apply an interceptor at the class level, but I can also apply an interceptor at the method level. If I have both, what's going to happen is that the method level interceptor is going to go first, and then the class level interceptors are going to go second. Again, if I have an ordered list, second, third, fourth, fifth, sixth, so on and so forth. If that makes sense. Yes.
The calculator log interceptor class. How does it know what method to call in there?
How does it know what method to call on the bean?
How does it know to call log calculation? What if there were two methods in there?
Say it a different way.
You've got a method, right, called log calculation?
Yep.
That's what gets executed when it intercepts, right?
Correct.
How does it know to do that? What if this class had two methods in it?
Yeah, you're only going to have one method that's annotated with the around invoke annotation.
All right. Let's settle that then.
Was that the question?
It is.
Okay. Yep.
Thank you.
Yep. Other questions?
Just say in your calculator class, for the multiply method, you were repeatedly calling the add method internally.
Yep.
Would that invoke the
interceptor? Yep. It would.
It would? Okay.
Mm-hmm.
And the interceptor has access to all of the properties within that method?
The interceptor has access to, let me pull up the slide. It's got access to the parameters. Is that what you're asking?
Yeah.
Like the variables that are passed in, yep.
Return value there is in any properties that I have within that method are available?
You can get the parameters that are passed in, right, through this. Sorry, let me back up. You can get the parameters that were passed in initially through the get parameters. You can override those parameters using the set parameters. And then you can access the return type through the object that's returned from proceed. Was that what you're asking, or are you asking a different question?
No, that pretty much explains that question. And then you said you can do pre and post processing interception. Do we see that in that example?
Yeah. So let me get back to this example. I'm going the wrong way. So here, so in this example, on the interceptor class, there is no pre-processing, because basically the first thing that I do in the try is I proceed, so I invoke the method, right? And then I do everything starting on line 23 through the end would be considered post-processing.
Post-processing, so after the method had completed.
Yep. But before the return is actually sent back to the caller. So so the client calls in this example, the client calls in, hits the proxy forwards the request to the interceptor. The interceptor does the add or does the multiply or whatever it is. That's lines 21 and 22. The multiply completes. I get the result that's stored in return value. And then I do everything line 23 through 30 is my post-processing. The client doesn't actually get the return until I get down here to 34.
Okay.
I got it down. I didn't understand that either.
So what happens if an exception is thrown in the post-processing and I want to send that exception to my JMS queue here?
Okay. Well, you would just catch it, send it to the queue.
So set a property or whatever, set a parameter that would be error text or whatever, and then access that parameter in the post-processing.
Yep. Yeah, I mean, like in that scenario, what you would want to do is let me clean up my arrows. Really what you would want to do is take that send and duplicate it and place it also in your catch. Right, so if I had success, I send the successful. If I had a failure, which, signified by an exception being generated, recreate a new message in my catch block and then send it.
But that would be an exception in my interceptor, not my method, that this is intercepting.
Right, so if an exception occurs in the method that you're so you're saying an exception occurs in the EJB, right?
Mm-hmm.
So that exception is going to propagate back up the call stack to the interceptor. So you're going to call right here, when you call ic.proceed, that's not going to actually return, right? Your return value is no longer there because an exception was generated. So you're going to jump down here to the catch.
So
and then you would do whatever you wanted to do.
So if my method that's being intercepted throws an exception, then I need to do the processing in the catch. of the interceptor.
Yep, or I've got to pass it up. Yep. Correct.
Okay.
So you could do a throw there, you're saying?
Sure. Yep. Yep.
That would pass it back.
I'm going to pass it back.
Then you do the return, and then your add function gets the exception. As you threw it. I'm thinking.
Mm-hmm.
Beyond this point, there'd be dragons.
Okay, thank you. I appreciate that.
Does that make sense or not?
Maybe not yet. I'm a little slow. I'll think about it later tonight, and the light bulb will go off.
So the other way to look at the interceptor concept in EJBs are almost directly borrowed from the filter concept in servlets. If you're familiar with that.
Mm-hmm.
They work nearly the same. So there's no, I guess the point is that there's no real pre-processing or post-processing magic, because I'm writing that myself. Right, I'm preparing to invoke the operation, that's my pre-processing, and my post-processing is dealing with the results of the operation in whatever way I want to.
Okay.
Sleep on it and then email me.
Okay.
In the AOP, like traditional AOP, there's other methods like just before invocation, like, and there's around and then there's after. So do we have those also?
Nope.
Okay, it's just around.
Just around. Correct. Yep. Yep. Well, there's no, like in other AOP frameworks, there's the pre and post that before and after that function as your pre and post,
Mm-hmm.
right? And this, it's entirely up to you on how you want to structure that.
Okay. Yep.
Yep. And then I mentioned this earlier, there's Lifecycle Interceptors as well. So obviously I just borrow the Lifecycle annotation, throw it in my Interceptor class when I move on with life. That's the example. That's this example. And then we haven't, the second example on that slide, we don't really have a lot of context for that because we didn't talk about the timer service, but if we did, and we looked at the schedule in the timer service, we would have the correlating at timeout method, and that's where that would be applied. Let's get this. So interceptor chaining, I mentioned this already. It is an ordered list. Talked about that. There is a way to create a default interceptor. So I'll just pull up the XML. The idea here is that instead of me defining interceptors in every single class, I just can define an interceptor basically at the application level, and then it will be applied to all the classes. So here's the example. Let me grab a different arrowhead. Here's the interceptor class name. And here I am applying the interceptor to every single EJB in my application. So now every single EJB is going to have the log capability turned on. And then here's an example of what that log interceptor would look like. questions on that? Questions on the interceptor piece?
Good.
Okay. So that's it. That's all I have for the EJB 3.0 discussions.
That's all?
That's it.
Okay.
158 slides later.
You did really good, Kelby. It's hard to do an EJB course in 4 hours, man. You did good.
Thanks. I was going to ask, I kind of alluded to this in the email yesterday, Robert. Do you want the content on EJB 3.1, or is that not relevant right now for the group?
That's a good question. It's not that we don't want to have it. I wouldn't want to make you produce it.
Well, so the 150 whatever slides that we covered today is pulled out of our Working with EJB 3.1 course.
Uh-huh.
So it's real easy for me to just convert the Working with EJB 3.1 course into a PDF, which is the full slide deck, and send that to you.
We would love it.
If you want it.
Yes, we would love it. That would be nice. Thank you.
Yep. Okay, so I'll shoot that over to you.
All right.
And then I was just under the assumption that 2 p.m. on Wednesdays works for everybody.
Yeah, 2
That's
p.m.
kind of what we've been doing?
Hour. Yeah.
Okay.
Keep it consistent, yeah.
Yeah, keep it consistent. Okay. So, and if you just want to let everybody know, it's not like they have to just ask questions on EJB. I mean, they can ask questions on JSF and JPA as well.
Okay.
So, if they ask me a question on SEAM, I'm not going to be able to answer it, but you guys haven't gotten there yet, so I think we'll be okay.
Okay, sounds good.
And Ashley will probably send out invites again for everybody on Monday, just as a reminder.
That's perfect.
For those office hours.
Perfect. Well, thank you for allowing us to have our break and going a little over time and everything. It was an awesome class, Kelby. Thank you.
You're welcome. You're welcome. Hey, enjoy the weekend, and I'll also shoot you a link over the weekend, Robert, to grab the recordings, too.
Okay. That sounds awesome.
Okay. Thanks, guys.
Thanks a lot. See you later.
Yep. Bye-bye.
Thank you. Please stand by.